This is the NASA Exoplanets archive report based on up to March 27th data. They started collecting, well, at least the data set here starts back in 1985 for planet observations, and it goes up till 2019. So, starting off, I did quite a bit of research on the columns, but I embedded this into the application here. You can actually see it in the app when you run it. There's an error right now, but the PowerPoint is embedded in there, so once I fix that error it should be fine. But anyways, here's how the app looks, and this brings up my internet page here when I do call this. So starting off, I have that PowerPoint for the research, and this is all based off of things that I did in my IPython or Jupyter notebook. I did tons of data exploration and came up with a couple of useful things. Came up with the clustering as well, which I use later. So getting to the first module, we have a packed bubble chart. This was done with RShiny and Plotly JS. So here, when you mouse over any planet, you've got planet name, host name, planet radius and Earths, and planet mass and Earths. And what you're seeing here is planet radii. Also, notice planet name here, UPS and D, and then the host name, which is the star, UPS and. Usually it's like host name A, B, C, D, with the planet names being A, B, C, and D. So I actually had them grouped together. So you see WASP, Kepler. I had the planets that were found grouped together by their solar systems and their names. So you could see all of them are clustered together. Hats. You got the 4 big hats right there, right? Also, you can click here, click on, click off, just to mark a planet. You found one that's interesting. You got a lasso here as well. You could do some interesting things with that and selections. Kind of a wide sweep. All right, going on to the next module. I decided to look at how many planets were being discovered per year and by which methods. So here's something I found that's interesting. I actually cut out the 1985 date because it was a single planet, so it was an outlier. But there's 2 methods. One is radial velocity. So in the beginning, and then there's transit. So these are 2 of the main methods. Look at a planet in transit, and the other is looking at its radial velocity. I don't want to get into the science, but in the beginning, it was mostly radial velocity, and not many planets were being discovered. And also the distance from Earth is what I'm looking at here. How far away are these planets that we're discovering? And then look, as soon as we hit transit starts getting into the picture, we can see that we're discovering a lot more planets that are much further, and it looks like the radial velocity stays about the same. So it's a little interesting little historical plot there. Okay, next on, this is the part where I'd like you to explore the known exoplanets. So looking at planet mass, radius, and this is orbital period. You can plot this. You can mouse over here. You can zoom in. So it's a nice little 3D interactive plot. So let's go ahead and pick eccentricity. Boom! It changes instantly. Planet mass. Let's do planet distance from Earth in parsecs, and then let's do optical magnitude for the y-axis. So you're really at your own freedom here to map it as you'd like. All right, and keep in mind this is also the clustering algorithm using k-means. It grouped them into 4 clusters, cluster 3 being the one that has the most 90% of the planets in it. So I'm about to show you a little bit more about the clusters right here. So cluster 3 right there in red is the one that had 90% of the planets. In purple, so cluster 4 had a lot of the big planets. So you can see this is a radial plot. So Earth is in the middle, and then you have the distance in parsecs out here on each concentric circle, and then you have the angle at which we found it. So you can also rotate this. If you look at this area, you can see all these red planets being clustered in this direction. That makes a lot of sense, given the way that they discover them. So I thought that was very interesting. The other planets are also purple too in that direction. So if you imagine if we found X amount of habitable planets in this one beam, how many would we find in the other beams? So quite interesting. But finally, there's my contact info. If you'd like to inquire more, let me know. Thank you.